make an educated guess.
At least get partial points, if nothing else. So use the intermediate value theorem to prove that the function f of x equals 2x to the fifth plus x squared minus 2 has a root between x equals 0 and x equals 1. Make sure you verify all the hypotheses of the theorem before applying it to draw the conclusion. So we have the 4 steps, just like I wrote. This is section section 1-4. Okay, so first thing intermediate value theorem says is f is continuous on AB. So is the function, so 2x plus, or 2x to the fifth plus x squared minus 2 continuous on the closed interval, and it's between 0 and 1, so 0 and 1. Yeah, so the function is continuous. It's a polynomial, so I know polynomials are continuous everywhere, so we are good to go with that. Then we need to show f of a. I'm just looking at the theorem. F of a does not equal f of b. So f of a would be the left endpoint plugged into the function, and then f of b would be 1 plugged into the function, so that's not too bad to check. So 2 times 0 to the fifth plus 0 squared minus 2, and this will be 1 to the fifth plus 1 squared minus 2, so negative 2, and 2 plus 1, 1, right?
Yep.
3 minus 2. They do not equal, so we are good.
I have a question.
Yes.
So like if I just did that simple math in my head, is that a problem?
I would have this written down, but then nothing other than that. Yeah, I would show this writing in, especially because I can get partial credit. So then 3, there's k is any number between f of a and f of b, such that, so you would need all of this on the theorem tomorrow, or on the test tomorrow. So k is any number between f of a and f of b. Then if k is any number between f a and f b, then there's at least one number c in a b such that f of c equals k. So f of c equals k, we're going to take, I want to prove that it has a root. So if I'm looking for a root, that is the same as x-intercept solution, root, x-intercept. There's one more word. 0. All means the same thing. So all that means is I'm looking when the y value is 0. So my k value is going to be 0 because I'm looking for a root. That means my y value is 0. So first of all, I need to show that k is between f of a and f of b. So k is between f of a and f of b, so we are good. So whatever k value you're looking for, in this case k is 0 because I'm looking for a root, which is on the x-axis. Yes?
So it's 0 because it's a root?
Yes. Because they want to show that it has a root. So k is 0 because a root is an x-intercept. So k is between f of a and f of b, negative 2 and 1. So we're good with there. So that was kind of the third step to show. And then we need to show if that is true, then there is a c in a and b such that f of c equals k. So f of c equals 0. F of c is just the function with c plugged in. And actually, this is a little different than some of the ones we had in the homework. They don't ask for c. So as you look at this, they're not asking for the c value. They're just saying use the intermediate value theorem to prove that it has a root. All we need to do is we need to show it. We prove that it has a root because that k value is between f of a and f of b. Because if you read the intermediate value theorem, it says, if f is continuous, we're good. F of a is not equal to f of b, we're good. K is any number between f of a and f of b, we're good. 0 is between -2 and 1. Then I know for sure that there is one number c such that f of c is equals to 0. We don't need to know what that c value is, but we know according to the theorem, there is one number c such that this equals 0. So that's showing that exists a root. It doesn't ask for c, which is good because this would be we would have to do q over p and whatever, rational root theorem. But it doesn't ask for c, it just says to prove that there's one that exists. And that's just showing all three of these are true. Okay. Questions on that one? This is why we're memorizing those 6, in case one like this shows up.
6 or 7?
There's 7 theorems I gave you, I'm pretty sure.
Yeah.
No, I gave 6. I said there's 6 theorems. I meant to say 6. I said 7. Should be 6.
You give us intermediate value theorem, fundamental theorem of calculus, extreme value
I have it
theorem,
listed.
mean value theorem, roll value theorem, average value theorem, and second fundamental theorem of calculus.
You said the second.
You told us to write it down fast.
Yeah, but not for the quiz. I would know that formula. Not the actual theorem, but know that formula. No, you need to know that formula.
Oh, you just need to know the formula. Not the
Right.
theorem.
Yes. I would be familiar with that. No.
Yeah, I see.
Okay. So let's look at 4. Again, this is another thing that you're not going to be quizzed over. I don't know if it's the actual theorem. Limit definition of a derivative. I would be sure we hit it hard on chapter 3 test study guide. You've seen it a few times, kind of pop back up. I would know this. You had to memorize it. It's not up there anymore, but you had to memorize this for that chapter 3 test. So you should at least be somewhat familiar with it. So that is the limit as delta x goes to 0. F of x plus delta x minus f of x over delta x. I would put this on your list of things to know for the final, in case you don't know it already. We've done ones like this before. We're going to use the limit definition of a derivative to find f prime of 1. So make sure you use this and not just take the derivative shortcuts. So start plugging in. Limit as delta x goes to 0. F of x plus delta x, you're going to take x plus delta x and plug it in where x is. So it's going to be 3 minus x plus delta x minus 1 over 3 minus x over delta x. So x plus delta x, you take x plus delta x and plug it in where x is in the original, minus f of x, which is just your function, all over delta x. Our goal with these limit definitions are always the same. I want to be able to take the limit and plug in 0 for delta x. So eventually I'm going to have to cancel out the delta x in the denominator. As I look at this, I'm going to go ahead. I could have done this all in that first step. So 3 minus x minus delta x minus 1 over it's kind of, you could have done that step together, but whatever. As I look at this, next thought. Yep, anytime you have complex fractions like this, we have multiple fractions. Common denominators is usually a good place to start. This delta x is over 1, so we're going to look at the top part and the bottom part. My common denominator is going to be what? Yep, just multiply them together. So my common denominator is going to be 3 minus x minus delta x times 3 minus x. Not bad, because I only have 1s in each fraction on top. Fraction on the left, I'm going to have to multiply by what?
3 minus 1,
3 minus x. Gotcha. So the left fraction, you're going to have to multiply by 3 minus x. The fraction on the right, I have a 3 minus x already, so I'm going to have to multiply by 3 minus x minus delta x. I'm going to go ahead and distribute the negative as I do it. So negative 3 plus x plus delta x. All over, as I get the common denominator and the denominator, the bottom, I'm going to have to, I have it over 1, so I'm going to have to multiply top and bottom by both of them. So delta x times 3 minus x minus delta x times 3 minus x. We've seen them before, nothing super brand new. Let's simplify some. The two denominators are going to be gone. The top will become what? Just delta x. 3 minus 3, negative x plus x is gone. And I have delta x times 3 minus x minus delta x times 3 minus x. Delta x's cancel, so I have limit as delta x goes to 0 of 1 over 3 minus x minus delta x times 3 minus x. Now I can actually take the limit. So up until this point, I was always getting 0 in the denominator, but now if I plug in 0 for delta x, that will just give me 1 over 3 minus x times 3 minus x squared. So I'm just going to put 3 minus x squared. Have I answered the question? No, I have not. Yep, so I want to know f prime of 1, so I'm going to take that, that's my derivative, and I'm just going to plug 1 in. So that will be 1 over 3 minus 1 squared.
Because we use this formula, and this gives
Yep,
us the first derivative.
correct. And you can easily check the derivative by doing like the, yeah, you could do quotient rule if you really wanted to. So 1 over 2 squared, 1/4. And then part B is taking it one step further like we've done before. Find the equation of the tangent line to y equals f of x at x equals 1. So, equation of the tangent line, first thing I need to remember is what?
And this is slope.
The slope of the tangent line is the what? First derivative at that point. We already found that in part A. The derivative at 1 is 1/4. So my slope is a 4th. We already did that in the first part. We found the derivative when x is 1. So that tells me my slope is a 4th. We've done this before. So y equals 1/4 x plus b. I need to find b. I don't give you an ordered pair. I give you x is 1, but no y. How do I find y? Yep, plug 1 into the original. So if I plug 1 into the original, that will give me 1/2. So we need an ordered pair. Sometimes they give you an ordered pair. Sometimes they give you x, but you know if you have x, you can plug it into the original to find y. So 1/2 equals 1/4 times 1 plus b. We've done before. Subtract a 4th. 1/2 minus a 4th. 1/4 is equal to b. So y equals 1/4 x plus a 4th. Questions?
As a class, how do you think we're going to do on this final?
I feel confident that if you look over all that I have the reviews, the final reviews we went over have covered what's going to be on the final pretty well.
Super duper.
How many more of these do we have left?
We'll see. I don't know off the top of my head.
It says find the equation.
Don't look
of
too
tangent lines.
excited. The more the better.
No.
That should be your philosophy.
Y, is that supposed to be y of y equals what? What is y equal to? For B, find the equation of the tangent line to y.
That's just saying y equals this. I don't, it's just kind of redundant.
What is it? Is it supposed to be f like f prime of x or f of x?
It's just f of x. It's just saying it just
It just didn't have a line. Okay. Well, it looked like
from this answer, because this is the derivative when x is 1. I did it in part A.
It looked like an
Yeah.
interval.
No, yeah, it looked weird. Yeah.
I was so confused.
No, I think if you guys look over the old finals, the old test I've given you, I feel pretty confident that the questions on the final are ones that you are familiar with if you look over the old finals and tests. So I feel comfortable with how I prepared you. So that's all I can do. But
Hey, question.
yes,
Do you know how you said like you prime out 1, 2, 3, 4?
yes,
Okay, can you look at this real quick?
yeah. Let me finish this. I'll look at it in a minute. So just leave it there. I'll look at it in a minute. So let's look at 5. Same idea. For the function f of x equals square root of x minus 1, use the limit definition of the derivative to find f prime of x. This is not f prime of 1 or 2 or 3, so we're just finding the derivative, not plugging anything in, unlike number 4. So limit definition, so limit as delta x goes to 0, the square root of x plus delta x, I don't really need parentheses, but that's okay, minus 1 minus square root of x minus 1 all over delta x. So I took x plus delta x and I plugged it in where x was for the first half, minus the function all over delta x. First thoughts? Anytime you're taking limits of square roots, we talked about them when we did limit definition. You want to multiply by the conjugate because it's going to look messy for a little bit, but it should work out nice eventually. So we're going to multiply top and bottom by square root of x plus delta x minus 1 plus square root of x minus 1 all over square root of x plus delta x minus 1 plus square root of x minus 1. We've done some like these multiple times. Top is just becoming FOILing, multiplying a binomial. So we have the limit as delta x goes to 0. First two, square root of x plus delta x minus 1 times square root of x plus delta x minus 1. Yep, so I just have the square roots cancel, so I just have what's underneath. Conjugates allow my middle terms to cancel out. So my last part is just going to be minus x minus 1, or minus x plus 1, whatever. Yes. All over delta x times square root of x plus delta x minus 1 plus square root of x minus 1. All of these limit definitions kind of follow that same step. You'll eventually be able to cancel out delta x. The top will become, x minus x is gone, negative 1 plus 1 is gone, so I just end up with delta x over delta x times square root of x plus delta x minus 1 plus square root of x minus 1. Should all kind of get to the same part with all of these. Delta x is cancel, so I have the limit as delta x goes to 0 of 1 over square root of x plus delta x minus 1 plus square root of x minus 1. If I plug in 0 for delta x, which I can do now, the bottom will become 1 over square root of x minus 1 plus square root of x minus 1. So that is 1 over 2 square root of x minus 1. Questions on that?
We don't plug anything in because this is
It's
all
just f prime of x, not f prime of 1 or 2 or whatever.
So you plug in 0 for the delta x.
Correct, because it's a limit, so yeah. Okay, any other questions on that? Okay, let's look at 6. We haven't done one like this on the review yet. So let f of x equals 3 ln of x over 2 minus ln of x. Find the formula for its inverse function, f negative 1 to x. So first thing I notice is it's just asking for the inverse, not the derivative. It's just f to the negative first. F inverse of x is basically how I do that.
Find the inverse of it?
Yep, just find the inverse. So we talked about this in chapter 5, I believe. And we had those steps to find the inverse. Let me get this focused. First step is I'm going to make this y equals.
And then we're going to stay right at
The first step is to solve for x, and then I'm going to switch x and y, and that will be your inverse. To solve this for x, first thought,
multiply by 2 minus natural 1.
yeah, let's get this out of the denominator. So I'm going to multiply by 2 minus ln of x, both sides. So that will leave me, I'm going to go ahead and distribute on the left. So 2y minus y ln of x. That would just leave me 3 ln of x. Trying to solve for x here. Thoughts? My x's are both with the ln.
Make it the exponent and then
Possibly eventually.
Shouldn't you just
do the
like?
Can we?
Shouldn't you just divide?
Oh,
by-
bring
shouldn't you just
add
divide
both
by
sides
2?
and then take out an ln x,
Yes. So I'm going to add at y ln of x to both sides.
and then we can eat it.
So yeah, so what I notice is these are both ln of x's, so I can combine them. So 3 ln of x plus y ln of x, I can actually take out ln of x and just have 3 plus y left. So since they're both ln of x, I'm going to factor out an ln of x, and that will leave me a 3 plus y. And then I like that because that gets a single x now. So I just have x with 1 ln. So then I need to divide by 3 plus y. So 2y over 3 plus y equals ln of x. And then finally to get x alone, yep, e both sides. So make then exponents to e. So I have e to the 2y over 3 plus y power equals x. So that was kind of a tricky one, solving it for x. So once you solve it for x, then you switch x and y. So f inverse of x is e to the 2x over 3 plus x. Been a while, but we've seen like something like it.
Hold on.
Yes.
You just combine those logs into 3 plus y?
We took out an ln of x.
Yeah, so this, I skipped the step where I wrote them next to each other. That's the same thing as this. And then I took out an ln of x.
Oh.
Oh.
Oh my. Can you do that?
Yeah.
Yes.
Because they're just in the front.
Yeah, the 3 and they're just being multiplied, so I can factor that
Are they
out.
technically exponents of that log, or does it matter?
No, I mean, no.
I thought you had to do some other swapping.
Oh
Because
my.
f of x is y, and I thought you had to switch.
No, f of x is y, but I'm looking for the inverse.
Yeah, I don't know. I set mine in terms of y instead of equal to x because I thought that's what you did.
Yeah.
But it
What is that?
doesn't matter.
What do you mean?
When you put it in y and
You set it equal to y.
solve it for x, but then, or solve it for y. and then-
Oh, that's when I'm looking for the derivative of f inverse. Where you do the 1 over and then you plug it in and then you... I think that's what you're talking about.
At the end, you switch your x to y.
Yeah, I did that here.
Yeah, I know. But like the beginning, we didn't switch anything out.
That's what I did. I did it. At the
In
beginning.
Algebra 2 and Pre-Calc, they teach it, you switch x and y first, then solve for y. It's the same thing. This is just how the book did it, so I was consistent with the
So
book.
you would start out x equals 3.
Yes, and then solve for y, and you'll get the same answer.
I thought you were supposed to. I'm so confused. I just made myself confused because I thought it was the same thing. I thought you were supposed to solve for x.
We did,
Yeah, we did. We just didn't switch them at the beginning.
and then we switched them
Combined
after.
them all and then separated them out again.
Yes.
I'm thoroughly confused.
I get if I get the notes out, I believe this is the steps we did. Solve for.
Like at the very beginning, you're saying like normally we would have x equals and then the y in there. They just did it. normally,
Yes.
And then spread it all
Yes.
out and then combined the x's on one side and the y's on one side.
Yes.
Yeah, but.
Instead of
Or
just-
no, I did it wrong. I never mind. I see what
Okay.
how I set it up. Yeah.
Okay, you're good.
Whatever. F of negative 1 of x is e to the 2. E to the 2. So it's 2y power? No, it's 2x. Right?
Oh, did you do it?
Oh, so we did do it right. You just swapped
Yeah.
it out the end.
Yes, yes. Either way you do it, it's
I
fine.
was so confused.
Okay, let's look at 7. So here's the function g of x equals square root of 4x squared minus 1 over x plus 3. I want to find the domain. Quick refresh on the domain. Couple issues I see here.
You can have a negative 3.
I cannot get a 0 in the denominator, and I cannot take the square root of a negative. So I know that x cannot be equal to negative 3 from the denominator. And I also need to figure out what values of x will give me square root of negative numbers on the top. The easiest way to do this is we are going to take the top, the part under the square root. Now you could take the whole top part and square both sides. You're going to get the same thing. Squaring 0 is the same. And this will tell me what x values will give me it equal to 0. And then that's going to help me decide how to set up my interval to check if it's positive or negative or whatever. Divide by 4. So x squared equals a fourth. Square root. So x is plus or minus a half. So if I plug in x values of positive a half or negative a half, it will give me zeros in the top. So that tells me how to make my interval so then I can see which values will give me 0. So as I look at this, I'm using negative a half and a half. So all I'm doing here is I'm checking my intervals to see which intervals give me back negatives when I plug them in. And then those are intervals that cannot be part of my domain because I cannot take the square root of a negative. So anything left of negative a half, let's plug in negative 1. If I plug in negative 1 up here, I get back positive because you get back square root of 4 minus 1, so it's positive.
I have a question.
Yes?
Why are we doing that thing? Why aren't both of them just in the domain?
Because if you get 1/2, you plug it in, you'll get 0, and you can take the square root of 0 and get back a positive number.
Right.
What do you mean, why aren't both in the domain?
So right now we're figuring out on which side of the interval, what part of the interval to put in the domain.
Yes.
Because everything left of negative 1/2, everything like negative 1/2 to negative infinity, it will result in a positive value.
Yes.
But from negative 1/2 to positive 1/2 may result in a negative value, so
So-
we can't include it in our domain.
So yeah, so I'm looking for what x values will give me square root of negative is what I'm looking for, basically. You good?
Yeah, it's kind of confusing at first because I was confused
Okay.
while we were doing it too.
We good?
Just do it and then I'll be able to.
Okay. So now let's check between negative a half and a half. Let's plug in 0. If I plug in 0, that will give me back square root of negative 1, which I cannot have. So I know the interval negative a half to a half will not exist. If I plug in anything bigger than a half, if I plug in 1, that will give me back square root of 4 minus 1, square root of 3. That is positive. So I know my interval is going to be, where I get positive values are negative infinity to negative a half and 1/2 to infinity. However, we also know that I cannot have negative 3. So it's going to be negative infinity to negative 3. Negative 3. Negative 3 to negative a half. and then 1/2 to infinity. Yes, technically, yes, use the use. I'm not used to that, but yes. So according to the other finals, the domain, yeah, use the union symbol.
Negative infinity to negative 3 in union with
Would
negative
the
3
half
negative 1/2 in union with negative 1/2 to 1/2.
Yeah, so if I look at halves, yeah, those would actually be in brackets because I could include a half. Yes, good catch. So yes, those halves and negative a half would be in bracket because I can take the square root of a 0. And negative 3 cannot be in brackets because I cannot include negative 3 because that will give me 0 in the denominator. So that's 2 domain.
So you just said both parties equal to. Oh wait, you can have.
Correct. I can take square root of zeros, but I can't have 0 in the denominator. So that's why there's not brackets at negative 3, but there is at negative a half and a half.
Yikes. You know what I could have just done instead? X could not equal negative 3.
And you would not have gotten all the points.
Yeah,
But
which is dumb.
whatever. Well, that's not the right answer. Well, it's not, but. Okay. So let's look at B. Now I want to find all of the horizontal asymptotes and vertical asymptotes of the function. Show necessary work and steps to arrive to your answer. So vertical asymptote is pretty straightforward. To find the vertical asymptote, what do we do?
Set the denominator equal to 0.
Bottom equal to 0, which we already kind of talked about. So my vertical asymptote would be at x equals negative 3, which we already kind of knew from talking about it in the domain. Horizontal asymptotes are a little trickier to find. Now, if I look at horizontal asymptotes, if we have nice polynomials over polynomials, you can use that shortcut where you compare the degree of the top and the degree of the bottom. However, since I have the square root on top, we are going to be looking at the limits. So the limit as x goes to negative or positive infinity, and the limit as x goes to negative infinity. Yes, because they could approach a different limit on the left and a different limit on the right. So square root of 4x squared minus 1 over x plus 3. So those are my functions. Anytime I'm trying to take a limit of a rational function,
Plug it in.
yeah, but this one's going to be hard to think about because I have that minus. And the square root kind of makes it weird.
You use the biggest.
Yes, divide by the highest exponent in the denominator. So this will become, so we use that shortcut where if I can get a constant over x to any power, that's 0. So this is going to be x over x plus 3 over x. And this will become, now I'm under the square root now. We've had some like this. So now it's going to be x squared. So on the bottom is x, but then when I think about putting it under the square root on top, it becomes x squared. So limit as x goes to infinity, square root of 4 minus 1 over x squared over 1 plus 3 over x. Using that formula, if I'm going to infinity or negative infinity of a constant over x to any power, that is 0. So 0, 0, square root of 4 over 1 is 2. You do the same process over here, but I'm going to negative infinity, so that's going to make it negative 2. So the same process, but since I'm going to negative infinity, that will make it negative 2.
How does that work?
I did that, but I just did back to the square root works plus or minus.
Yeah, that's fine.
What?
Because I can have negative, so whether or not I plug in positive x values or negative x values, I can get negative 2. So if you're going to negative infinity, since I have that square root, I can have that negative 2.
So you would have gotten negative 2 either way because square root of 4 plus or minus 2, right?
You could think about it that way. That's
So
fine.
it's
Yes.
it only works like that if you're going.
If we have square root. Mhm.
So if it's going to negative infinity, but there's no square root in the numerator or denominator, then
I believe yes.
it'll just be whatever the number it is you get.
It would be the same. I believe yes.
Okay, so when you're checking horizontal asymptotes, when you know when to do like the limit as infinity, positive infinity, or negative infinity versus like it approaches from the right and from the left?
If you're looking for horizontal asymptotes, you're going to check both.
Yeah.
Because the horizontal asymptote on the left and the right could be different, technically.
But like here we did the limit as x equals infinity versus the limit as x equals negative infinity.
Yes.
But then on other problems we would do like as x approaches this from the right or as x approaches this from the left. Like how do you know which one to use?
It depends on what they ask. Would need to look at a specific one. I can look at some of the old ones and see what I can find. I don't know exactly how to answer that.
Because like this one we use the infinity, negative and positive because it's
Yes. Yes. No, I'm looking. Okay, we'll try to get one more done. Actually, it's the last one. Okay, so let's look at this one, last one, and then let's look at the stopping point. Okay. So we have a piecewise function. Kind of weird. This one takes not a lot of work, just kind of thinking. Determine if f of x is continuous or discontinuous, differentiable or not differentiable at the following points. Write yes or no in the following table. There is no need to explain your answer. So let's look at good or bad. No partial credit. So let's look at when I have an x. This is a piecewise. So you have to look at your x values and decide what piece you're going to use. So if my first x value is -2, I'm going to use which part? The top one. X is less than 0. So first thing we're going to check to see if it's continuous is I'm going to plug in -2 and see if I get back something where I don't get 0 in the denominator. So -2, if I plug it in, I get back 1 minus 4 over -1. So I get back 3. So yes, it's continuous. Because I get back an actual answer.
That's all you have to do?
Yes.
That's what determines if it's continuous?
Yes. So continuity, it's continuous if there
at that
exists.
point.
Yes, there exists the point there.
Okay.
Differentiable is we are thinking about, can I take the derivative at that point? So as I think about, same idea, what they want you to see here is continuity and differentiability. So it may be continuous, but not necessarily differentiable. So we talked about this. If you have vertical tangent lines, something like this, which we don't worry about a ton, usually where we wind up with issues is where I'm going to have sharp turns, like we talked about before. It's still continuous, but it's not differentiable there. So if I think about this, at x equals -2, if I kind of think about the graph of this, yeah, you're not going to have a sharp turn. The sharp turns really only come from where you have absolute value functions.
Yeah.
So it's going to be differentiable there.
Yeah.
Because it's just going to be a normal curve, like whatever. -1, again, we're going to use the top one because -1 is less than 0. Is this continuous at -1?
Nope.
No, because you will get 0 in the denominator. So it's like kind of, we've already talked about it. So you're either going to, I would assume you would have, actually you may have a hole there because you can factor the top, but whatever.
You got food or something?
I know, you'll get to spend more time with them.
She quit coming.
Who? Oh, she did? Oh, nice.
Hey,
Yes.
the word on the street is that you are on a field trip on next Wednesday. Is that
No.
true or is that a lie?
Some student council kids are going. I'm not going. Yes. I know my schedule. You think I'm not going to know I'm on a field
The kids were
trip?
saying that you said you weren't going to be here.
Oh, I'm not.
We're trying to learn.
Huh?
I'm not.
What are you talking
I'm not
about?
there.
Us couch students have to take a final.
Hey, I'm not gonna have them quiz with you. I'll just have them work on the packet. That way you don't have to worry about it.
Sure.
And I don't think they want to do a packet tomorrow. So
Why would you? Because it's amazing.
Are we handing out free food?
apparently we're also disrupting teaching too.
I'm so
Oh,
sorry.
I don't want
Look,
to.
I'm sorry.
Healthy food.
Actually, it's fine because you're watching them. So
I'm so sorry.
Ew.
Thanks.
okay, bye.
Thanks all, Bob.
Word on the street.
I don't like that.
Okay. No.
Carrots too.
So let's finish this real quick. So is it differentiable at -1?
Yes, L'Hopital's.
Well, it is, but it's not.
Because it's indefinite. You get 0 over 0.
Can't you still take the
Right, but at -1, I know I'm gonna have.
Zero.
undefined?
So I'm either gonna have an asymptote or I'm gonna have a hole. It's not differentiable at asymptote or a hole.
Oh, so it's no.
So no.
So if it's no continuous, it's no differentiable?
Not true.
Yes.
Yes, true.
But if it's differentiable, it's not. If it's continuous, it's not necessarily differentiable.
But if it's
differentiable, it should always be continuous. Because you can't take the derivative at an x value that there's an asymptote or a hole.
Neato.
Okay. If I look at 0, 0 will be what part?
The middle.
In the middle.
You like the-
The middle part is absolute value. So let's just sketch this real quick. This is an easy absolute value. It will be that the v shifted to the right one. Something like that. So if I plug 0 in, does this graph exist when x is 0?
Yep.
Yes, it's 1. As you can tell by the graph, or just plug it in. So yes. It says right, yes or no. So follow the directions. I don't have to take points, but plus or whatever.
Yeah, so if we didn't write yes or no.
I probably wouldn't, but if x is 0, is it differentiable? Well, look at the graph. It exists, so yes.
Oh, what? Oh, you said continuous. Yeah.
That is not right, so that's not continuous. Actually, it is continuous.
I'm gonna say yes.
Why?
For differentiable? Because you can differentiate that.
Yeah, because there's a slope of the tangent line there.
But I
They
thought
go
you
back
said
and forth.
absolute value.
Yeah, but at the point, at the sharp
The next
turn,
one is no.
that would be
The
1.
next one is continuous, but not.
The next one is continuous,
Not differential.
but it is not differentiable at 1 because that's where my sharp turn is.
And then the next one is continuous.
And the next one I would have continuous. Is it continuous? No. At 2, I am here.
Greater than.
Does it exist when it's
Yes.
2? Yes. Why do I have no? If I plug in, I can plug in and get 4. So it is continuous. Is it differentiable
You know it.
at 2?
Buddy.
I would say yes.
So what constitutes a sharp turn?
This absolute value is usually what you're going to have.
Because if you look at
Or you that graph,
at 0,
or like this.
that point is right.
This would be a sharp turn.
So basically that only applies to absolute.
Indeed.
This would not be considered absolute value. It's not
So
necessarily,
that's not actually value.
but it's a sharp turn.
Can we go through the last 4 on this one?
Okay, let's look at the integration packet. I'll go
You
through.
should do the
So,
very last.
last 4. Last 4.
But if
I just need you to do the one that's in terms
Here.
of
They give you the setup on the key.
Yeah,
but I
So
don't know
only
how
if
it
it's
goes.
shifted this way
Yeah.
is it
because you
yes.
didn't, you graph it.
I tried to grab it.
And then
Differential.
I even plugged it into this, but then they go across.
Yeah, they do.
So these are ones we started with yesterday.
But, wait, no, north.
So let's see. Okay, listen up, please. So these 5 are tricky. Probably the one you're going to see on the final aren't going to be this hard. However, it's not. It doesn't hurt you to practice. I'd rather you do hard ones and then easy. You feel like it's easy on the final. So as I look at this, we have on the key. If you look at the key, they have it basically set up for you. So just look at the key and they'll kind of help you with the setup.
Well,
Um,
you do have to, well, yeah.
you have to integrate it, but it at least gets it set up. So if I look at 67, it's in terms of y's. We did some like it. So now that it's in terms of y's, we're going to have to go right minus left instead of top minus bottom. So let's set them. Actually, we don't have to set them equal to each other because we already know they're between the two y values. So the only point now that setting them equal to would be helpful would be graphing it, but I think we can get a graph without it. So if here's a graph,
They don't.
well, yeah, so, yeah, that's a good point. Yeah, we should probably actually do set them equal because they may intersect. So let's just do that real quick. I was trying to be lazy and not do it, but. No, you're fine. Okay, so go ahead and let's set them equal like we've done before to see where they intersect, and then that will kind of help you see how to set up your integration. I would get rid of fractions first, multiply everything by 2. So negative 4y plus 2 equals negative y squared plus 2y plus 9. That's my first thing. I would get rid of all your fractions. Multiply everything by 2. I'm going to add y squared over, only because then I'll have a positive 1 in front of y squared. It may make factoring easier. So add y squared over, subtract 2y, so negative 6y, minus 9, negative 7.
But then having numbers on top.
Factor this. This will be y minus 7, y plus 1. So these intersect at 7 and negative 1. And it is nice that we did this because we are negative 1. 7 is not on between negative 2 and 3, so we really don't have to worry about 7. It may help you to get your graph, so we'll just go ahead and graph real quick. Let's find what the... Now, be careful, because it's in terms of y's. So these are y values, not x values. Easy mistake, because we're not used to doing in terms of y. So if these are the y... If these are... Almost done. If these are the y values, we're going to plug them in to find the x values. So negative 14 plus 1, negative 13. Negative 1, so 2 plus 3. So negative 13, I'll draw a better graph. Negative 13, 8, 9, 10, 11, 12, 13, 7, 1, 2, 3, 4, 5, 6, 7. Somewhere up here. 3, negative 1, 1, 2, 3, negative 1. Something like that is where they're going to intersect at. If I graph this, if I graph y equals negative, so I'm only worried about between y equals negative 2 and y equals 3. So here and here. So I'm just going to, let's just plug in points and see. So if I plug in negative 2, let's see. Let's graph this real quick. This line we can graph. So if I solve it for y, x minus 1 equals negative 2. I'm solving it for y, so I can graph the line. So negative a half x plus a half, of course. So up a half and then down 1, right 2, somewhere like that. And then I can also go up 1, left 2, some up 1, left 2, something like that. It's not perfect, but it's close enough. So there's my line. I don't have to go all the way out to here because I'm only worried between negative 2 and 3. This next one, I would just kind of plot in some points. I think it's going to be quadratic, but let's just make sure. When y is 0, what is x? Ugh, yes. So when y is 0, x is 4.5. 1, 2, 3, 4. So somewhere there.
You said that was 0.
Yes. When y is
2.
let's just plug in -1 to see, because I'm really only going from -2 to don't do this one.
Are you kidding me?
Just don't. It gets too messy. Don't worry about it.
Oh my
Sorry,
God.
I tried. It's not worth it.
Oh my.
There's more important things I want you to focus on.
Like half, doing this thing, ask you a question, Mr. Keller gets too free, like,